All right, so today we're going to be talking about lunar eclipses. And so on IMB 26, we have a short, very, very short 2-paragraph reading on lunar eclipses. Excuse me. In a lunar eclipse, Earth comes directly between the sun and moon, blocking the solar energy from the sun. This alignment places the moon in Earth's shadow. When the entire full moon falls within the darkest part of Earth's shadow, or umbra, we have a total lunar eclipse. Everyone on the night side of Earth, half the globe, can see the eclipse. Depending on how much dust and how many clouds are in Earth's atmosphere, the moon will appear dark brown, red, orange, or yellow. This happens because light from the sun passes through Earth's atmosphere, which refracts the sunlight around Earth so that it falls on the moon and creates a glow. This term refracts is not one of our vocabulary terms, but it stands out to me because I don't use it on a day-to-day basis. So I'm going to just go back up through this paragraph and see if there's some parts that I can identify as helping to explain lunar eclipses and see if I missed any vocab. Let's see here, full moon, that's one of our vocabs, and umbra is one of our vocabs. Typically, I don't do a lot of highlighting in the first paragraph, but this reading just got right to it. So we have the Earth coming directly between the sun and moon, blocking solar energy from the sun. This places the moon in Earth's shadow. When the entire full moon, darkest part of shadow, the umbra, we have a total lunar eclipse. All of that helps describe what causes a lunar eclipse. So I'm going to go ahead and highlight that. I think I did purple last time. Let's do orange today. I like orange. So Earth comes directly between the sun and moon, blocking the solar energy from the sun. This alignment places the moon in Earth's shadow. So a lunar eclipse is the shadow of the Earth falling on the moon. And then when the entire full moon falls within the darkest part of Earth's shadow, or the umbra, we have a total lunar eclipse. Remember, to get a solar eclipse, we need a new moon. And so for a lunar eclipse, we need a full moon. I'm going to put that here. Add a little note. Total, so what am I doing? Lunar eclipse. The full moon. I don't think I need total. I can just say lunar eclipse equals full moon. And on the same plane. We need that same plane again, like we do for a solar eclipse. Same for a lunar eclipse. A little note there. All right. A partial lunar eclipse occurs when only part of the moon passes through the Earth's umbra. Remember the umbra, that's the darkest shadow. And a penumbral lunar eclipse, that's another one, another type of lunar eclipse. So we've got a partial lunar eclipse and a penumbral lunar eclipse. Occurs when the moon passes directly through only the lighter part of Earth's shadow cone, the penumbra. Neither of these lunar eclipses is as colorful as a total eclipse. Penumbra is one of our vocab words. Lots of vocab. All right, so I am looking here. This whole thing explains the penumbral and partial eclipses. So let's see. I think I want to highlight a partial eclipse occurs when only part of the moon passes through the umbra. I want to highlight that. And then what I'm going to do, instead of highlighting this part about a penumbral lunar eclipse, I'm actually just going to draw an arrow because there's a great picture of it here. This example right there is of a penumbral lunar eclipse. Maybe we should drag that all the way over to our moon. There we go. Make it so I can actually see it. Nice light color. There we go. All right, and then this one here has the total lunar eclipse. So I'm going to go ahead and do an arrow for that one too. Total lunar eclipse. There we go. Call that good. Highlight that. All right, so in order to get a total lunar eclipse, we need a full moon at the same time that we have the moon and Earth on the same plane. And then for a partial lunar eclipse, we need the moon to pass through part of the umbra shadow. And then for a penumbral lunar eclipse, the moon is passing through the penumbral shadow. All right, guys, today we're talking lunar eclipses. So just a reminder, for an eclipse that occur, we have to have the full moon for the lunar eclipse. And the moon must be on the same plane as Earth. Again, this is a model that shows the orbital plane of Earth. That's what this line is. It shows the path Earth takes to get around the sun. And then the orbital plane of the moon, that's this tilted orbit here. And this is what gives us full and new moons every month. Every once in a while, about every 18 months or so, the moon happens to be on the same plane as Earth at the same time as that new or full moon. And when we get a full moon on the same plane as Earth, we get that lunar eclipse. So again, we're using the Sun Earth Moon board to show the tilted orbit of the moon. And we have the same setup as before, where we've got the Sun Earth Moon board orbiting the sun, and then the moon orbiting Earth. And you can also see that. We're going to go for a little walk here. You can see that here. There's my setup. Each of those positions on the outside is where the Earth goes as it orbits the sun. And then remember, the sun goes in the middle. So I'm going to turn out some lights. All right, here we are. Get my sun on. And remember, what we need is we need that full moon. So the full moon happens when the moon is on the other side of Earth from the sun. And so we can see our beautiful full moon there, because the Earth is lower than the moon. Can we see the moon from here? There we go. Because the Earth is lower than the moon, it is not casting a shadow on the moon, so we don't get that eclipse. So in this position, there's no lunar eclipse. But time goes on. About 3 months later, the Earth is repositioned about 90 degrees from where it was. And now in order to get that full moon, we need to move the moon over to this position, and we can already see just by looking at it, the Earth is at the same level as the moon. So we just are not going to be able to see the moon. It's going to be shaded, which you can see. I have to pick you guys up so you can see it. No full moon there. This is a lunar eclipse in this position because the Earth is casting a shadow on the moon. And then time goes on. We relocate. Different time of year. New season. In order for us to get that full moon, we're going to need the moon to be on the other side of the Earth from the sun. And then from this position, look at that, even just where I have it. There's a shadow on the moon, but that is only because the Earth is on a stick. Of course, the Earth does not sit on a stick, so we wouldn't have that shadow there. But you can see that full illuminated moon. And then because the moon is down below the Earth in its orbit, we do not have that lunar eclipse. So we get our full moon. And then you know the drill. We keep orbiting around the sun. New season. And now we're on this side of the sun. To get that full moon, I need to put the moon on the other side of the Earth from the sun. And from where you are sitting, you can tell we cannot see the moon, which means that they're on the same plane. And so the Earth is then casting that shadow over the moon, resulting in that lunar eclipse. And then 3 months later, we move again, and we are back in our original location with our full moon being, oh, I thought my computer was gonna drop, my full moon being up high, too high for an eclipse. So we can see that again in our observation. We have our full moon. Of course, again, this is two-dimensional, so we don't get the different heights of the moon. But if you remember, this was our shortest position, and this was our tallest position. So when we have that full moon over here, the moon was too high to get the shadow from the Earth. Over here, our full moon was at the right height, so we got the shadow from the Earth. And then over here, the moon was too short, it was too low, so we didn't get the Earth's shadow on. Oops, excuse me, this is our full moon. We didn't get the Earth shadow on the full moon there. And then from here, the full moon again is at the right height. This is a little misleading because it makes it look like we get eclipses every 6 months. That is not the case. Our orbits aren't quite this precise and matched up. So we actually get these eclipses about every 18 months. But this really helps us to see some of the factors that need to be working together in order to have those eclipses occurring. You have to have a new or a full moon, and then the sun, Earth, and moon all need to be on the same plane. And so that does not happen every month. That's why we get those beautiful new and full moons every month. All right.